everyone! So for today, we'll be working on the solution for problem set 5, which is speller. So for this problem set, what we want to do is to implement a program that spell checks a file using a hash table. So we need to first load a dictionary of words from disk to memory and use that to spell check a file. So when the program runs successfully, the output should contain the following information: a list of misspelled words, a summary of the number of words misspelled, words in a dictionary, and words in a text. Then, we also want to see the time that your program spent executing the load, check, size, and unload functions. So we need to implement our functions as efficiently as possible to reduce the time spent executing the functions. So let's first look at the files that we are given. So we have speller, and this contains the main program to spell check a file after loading a dictionary of words from disk into memory. Next, we have dictionary.h, which contains the prototypes for the 5 functions. Then we have dictionary.c, which contains all the functions that we are going to implement. So what this means is that for this particular problem, we'll only be working out of dictionary.c. Then we have makefile, which compiles all our files together into a finished program. And then dictionary/ is actually a folder containing a large and small dictionary of words. The text folder contains sample files that we'll run our spell checker on. And keys, which contains the solutions for us to verify if our spell checker works correctly. So what do we need to do? First, with the dictionary file that we are given that consists of all the words in the dictionary, we need to do the load function. So in the load function, we actually want to load all the words in the dictionary into a data structure like a hash table. Next, we run the hash function. So this will take a word and run a hash function on it, returning a number that corresponds with the word. So in this illustration, we have the word apple. And with the hash function, we should actually get a number that tells us which index in the hash table it belongs to. That is, it actually tells us which bucket this word should be put into. Next, for the size function, it will return how many words there are in our dictionary. And for the check function, it will actually take a word and answer the question, is this word in the dictionary? If the word exists in the dictionary, it will return true. If the word does not exist in the dictionary, we will return false. Then we have unload, which will free any memory that was allocated to store data inside of the data structure. So before we move on, if you enjoyed the videos here so far, please do remember to like the video and subscribe to my channel, as this helps to tell YouTube that my videos are helpful, and it definitely helps increase my channel's visibility. And thank you so much for your support. So continuing on with where we left off, what will be the functions to code? So there are actually 5 in total. So they are load, hash, size, check, and unload. So let's first start with load. Now, let's start right from the top to get the right context on what we are supposed to do. So in the lecture, we actually learned about hash tables. And by creating a hash table, we are actually creating buckets that would enable us to better organize our data. It is up to us to decide how many buckets we want to organize our data into. So in this walkthrough, our hash table will be based on the number of buckets being 26, as my buckets will be from A to Z, where the first letter of each word corresponds to the bucket it belongs to. So in this example, the text I have can be apple, bear, cat, ball, and big. So when I put the words into my hash table, it will look like this, all the way to the last bucket where words starting with Z will be parked in. So how does this system know which bucket to assign each word into? So this is what our hash function is for. So in the hash function, the system will take the word as an input, for example apple, and then it will output a number that corresponds with the bucket it belongs to. So in this case, since the word apple starts with A, it will go into the first bucket. Likewise for the words bear, ball, and big, it will go into the next bucket, and words like cat will go into the following bucket. So you can see there's also a linked list within each bucket. Now, how are the words arranged within each bucket? Okay, so in this case it's also known as index of the hash table. So at each index of the hash table, there will be a linked list consisting of nodes, where each node will consist of a word and a pointer to the next node. So remember that a word is a character array, and the pointer gives us the address of the next node in the linked list. So that would be actually the address of the adjacent node. So in the distribution code in dictionary.c, we're actually given a type def struct of a node, where it consists of a word and a pointer to the next node. So here's what the node looks like, and in this case, the word is bear. So as discussed, a word is a character array, represented as char, word, length plus 1. So why is it length plus 1? So remember that characters stored in a string will have a null character at the end, which signifies the end of a string. So that is why the length of the word is taken to be length plus 1. Then we also have the pointer, which will point us to the address of the next node. So the hash table will give us the first node in the linked list, and its pointer will give you the address of the next node, which will bring you to the next node, and the next, until you reach the end of the linked list, where the address of the next node will be now. So how do we add a new node to the linked list? So in this example, we're actually trying to add the word book into the list. If we just point the head to the new node, we will actually lose the rest of our nodes. Instead, what we should do is to actually take the node and set its pointer to the current first element in the linked list, and in this case it's bear. Then we can set book such that it now becomes the first node in the linked list. So what do we need to do for the load function? We need to open a dictionary file and return null if the file cannot be opened. Then we will need to read the strings from the file one at a time. We will then create a new word for each node, hash the word to obtain a hash value, and insert the node into the hash table at that location. So let's start with the first step, and that is to open the dictionary file. So we should be moderately familiar with how to open a file. So it will be file equals to fopen dictionary, and R which stands for read. Okay, if the file cannot be opened, it will then return null, and we will print this error message and return false. Next, we need to read strings from the file one at a time. So we will scan the dictionary to look for words. So as we recalled earlier on, a word is a character array, so it will be represented by word length plus 1. How do we know when we have reached the end of the dictionary? So according to the CS50 walkthrough, we can actually use fscan to do so. So fscan will actually return EOF once it reaches the end of the file, where EOF stands for end of file. So what we want to do is that as the system reads strings from the file one at a time, we will create a node for each word until we reach the end of the file. So the code will actually look like this. So our comments now will be that it will read strings until we reach the end of file, and we will declare a character array called word length plus 1. So now we need to do a while loop, because as long as we can read strings from the file and the system does not return EOF, we will create a node. So that would be while fscan does not equal to EOF, we will create a node. So as we create a node for each word, we will actually allocate memory for the node. So it will be malloc size of node, which we covered in lab 5. So how do we know the size of a node? So in the distribution code, we already have the struct of a node provided to us. So this is a section below that actually is already in the distribution code. So that's why when we do malloc, we can just do malloc size of node. Next, we will return false if malloc fails. So if n equals to null, we will return false. So up to this step, we have allocated memory for the node. Now that we have our nodes, how do we copy a word into it? So according to the CS50 walkthrough, we can actually use stir copy, which will take a string and copy it from one location into another. So in stir copy, it will look like this, where n arrow pointer word is the pointer to the destination array, where the string is to be copied, and word is the string to be copied. Now that we have our word in a node, how do we obtain the hash value, which tells us which bucket we should put this into? So in our code, we will just obtain the hash value by using the hash function, which we will do later. At this stage, we have our node and the hash value, so we know which bucket it goes into. Now we need to insert our node in and do the linkages correctly. So as discussed, we will first set the pointer of the new node to the current head of the table. Then we will set the new node to the head of the list. Then we will close the file accordingly. Also note that we need to keep track of the number of words in the dictionary, so we will also declare a word count that will increase as we read this file. So let's put this in C. So as discussed, what we'll do is that we will open the dictionary using file open. And if it's not able to open, we will return null. So we can just write an error message, so in the event the file cannot be opened, at least we know what went wrong. Okay, so after that we'll declare a variable called word, as we discussed, so word will be length plus 1. So this is where we'll start off our while loop. So as long as we do not reach EOF, we will continue to go through the dictionary and look for strings. So we'll do allocate memory for each new node created, so that will be where our malloc comes in. So in the event the allocation of memory is not successful, we will need to return null. Okay, so if the memory is successfully allocated, we'll move on to the next portion. So this is where we will copy the word from the dictionary into our node. Then after that, we will obtain the hash value using the hash function. So this tells us where to place the node. And we also have a word count where we're actually keeping track of the number of words that we are finding in the dictionary and putting into nodes. Then we will close the file. So because we have declared a few variables, what we need to do is that we need to declare the variables that we're using. So for example, I'll just put in a section here where we will declare variables. So the first one we'll have is an integer called word count, and we also have a hash value, so we have to put that in as well. And because of the different code that we're using, we need to include other libraries. So some of it would be, for example, we need to include string.h. We also need to include this one and one more. Okay, and that will be that for load. Next, let's work on hash. So this function will take the word and return a number that tells you which index it belongs to in the hash table. So the word contains alphabetical characters and possibly apostrophes. So the output should be a number between 0 and n-1 inclusive, and the hash function you choose should depend on your n value. So the hash function you choose should also factor in what is your n value, so that is how many buckets you have. There are different examples of hash functions. It could be based on just the first letter of the word. So for cases where n equals to 26, the first letter of each word corresponds to the index that it belongs to, or the first two letters, or all letters. So in the distribution code, there is a sample hash function provided, but we are called to improve it. So this is what it looks like. So in this sample, the hash function we are given here is return to upper word 0 minus a. So let's understand this first. So this hash function returns the value of the first letter. So to upper word actually converts the first letter to uppercase first, then we will convert the letter into a number. This number will tell you which index in the hash table it belongs to. So do note that this hash table only works when n equals to 26, since we are grouping the words based on its respective first letters. So how do we convert this first letter into a number? So this is where our ASCII chart comes in. So let's focus on the uppercase characters. So you can see that A is 65 on the ASCII chart and Z is 90. So a word that starts with the letter B should go into the second bucket of the hash table, that is table 1. So how do we get this? We will need to take B minus A equals to 1. So bringing back the hash function given, it actually shows us how a basic hash function should work. So how do we make it better? So perhaps we can look for a hash function that can apply for whatever value n is. So that is, regardless of how many buckets we have in our hash table, the hash function will still work. So according to the CS50 walkthrough, we are told that we can look online for hash functions as long as we credit it and modify it a little. So I found one and I'll credit the website in the video description below. I've modified it a little to suit our requirements, where I basically inserted to lower in the function because we want to work with all lower cases. So what this function does is that it sums up all the characters in a word and then we'll divide it by n, which is the total number of buckets that we have in the hash table, and the remainder will tell you which bucket the word belongs to. So if I modify the hash function, it would be unsigned long total equals to 0, so where total currently represents the sum of the ASCII values of all the characters within my word. And then after that, I'll do a for loop to go through every character within my word, and I'll sum up the respective ASCII values, and then I'll return the total and divide it by n, where the remainder tells me which bucket the word belongs to. So let's look at an example for this. So let's say n is 26 and the word is apple. So the ASCII value is 65 plus 80 plus 80 plus 76 plus 69, which are the respective ASCII values of A, P, P, L, and E. And the total will give me 370. Then I'll take 370 modulo 26, with the remainder being 6, and it goes into the 6th bucket. So this will actually apply to all words that we are spell checking with. So now let's put this in C. So next what we want to do is that we'll improve the hash function. So let's delete this one that they provided us with, and now we will declare a variable called total. So that will be the sum of the ASCII values of each word that we're looking at. So we will go through each character in the word, and we will add up the ASCII value of it, where we will first convert each letter to lower, so we only work with lower cases throughout. So now that we have the sum of the ASCII values of our word, we'll divide it by n to get our remainder, which will tell us which index it belongs to. And that is pretty much that for hash. Next, let's move on to size. So the objective of size is to return the number of words in a dictionary. So for this, simply put, as long as word count is greater than 0, we will just return word count. And this is quite straightforward, so let's put this straight in C. So for size, as discussed, if word count is more than 0, which means that we actually have counted in words, we will return word count. If not, we will just return 0. And that's actually quite straightforward for this one, so that's all for this particular function. Next, let's move on to check. What this function needs to do is that we need to check if the word exists in the dictionary, where we will return true if it exists and false if it does not. It should also be case insensitive. So let's break this down into smaller parts. So first, for the word that we are spell checking, we will use the hash function to get the hash value, so it tells us what bucket the word may possibly belong to. So for example, if the word is book and our hash table is based on the first letter of each alphabet, the hash value will be 1. So that tells us to look at table 1, where all words starting with B will be located. Now we know which index it is in, we will access that linked list and traverse it, going through each node and looking for that word. To do so, we will use stir case comp to compare the word against the word in each node case insensitively. If the word is found, we will return true, else we return false. So how do we traverse the linked list to look for the word? According to the CS50 walkthrough, we can set up a variable called cursor which initially points to the first element in the linked list. Then we will check if this is the word we are looking for. If it is, the system will return true. If it does not match, then we will take the cursor and move it to the next node in the linked list. So to do so, you will need to set your cursor to be equal to the next pointer that it's currently pointing to. So to do so, you will need to set your cursor to be equal to the next pointer of where you are currently at. So as long as the word in each node does not match the word we are spell checking, the cursor will need to keep moving down the line until we reach the end of the linked list and the cursor will become null. So when we reach null, it means the word is not found in the dictionary and is hence misspelled. So the function will return false at this stage. So in summary, to traverse the linked list, we need to start with the cursor set to the first node in the linked list, then keep moving the cursor down until you get null as you check each node for the word. So let's see how the program should work. This is the function in the distribution code for check. So let's first start with obtaining the hash value of the word by applying the hash function. So we'll declare an unsigned integer called hash value using the function hash on the word that we are spell checking. Next, we will access the linked list at the index in the hash table and traverse it to look for the word. So we will first point the cursor to the first node. So that will be node cursor equals to table hash value, because we are setting the cursor to the head of the linked list. Then we will go through the linked list. So while the cursor does not equal to null, we will continue to go through each node and use stir case comp to compare our word alongside the word in each node. If it matches, it will equal to 0 and we will return true. If not, we will move the cursor to the next node as such. So let's put this in C. So for check, we'll use the hash function to get the hash value of the word that we are spell checking. So this is where we'll set up our cursor first to be the start of the linked list. So now we will start to traverse the linked list. So as discussed, as long as cursor does not equals to null, which means that we are still going through the linked list, we will use stir case comp to compare the word that we're looking at with the word in each node. So if it matches, it will actually return true, which is 0. Right? Then we will return true. Okay, if it doesn't match, then we will move the cursor down to the next node. And then we'll just keep doing that. Okay? And because of this, of what we have just keyed in, we actually need to include another library in. So that would be strings.h. And that would be that for check. Next, let's move on to the unload function. So this function actually frees up any memory that we've allocated in the process of running the spell checker. So remember that we used malloc in our program. Now we need to free up the memory and return it back to the computer. So when it successfully frees the memory, it will return true. So we will free the memory that was allocated when creating each node, and we will again travel through our hash table, going through each linked list and freeing memory allocated for each of these nodes. So how do we do this? According to the CS50 walkthrough, we can set up a variable called cursor, which initially points to the first element in the linked list. So to free memory in this first node, we could use free cursor, where we take what the cursor is pointing to and free the memory. But what happens if we do that? We will end up freeing the memory that stored the next pointer, which points you to the subsequent nodes. So you actually lose access to the rest of the linked list and you are no longer able to free memory. So what should we do instead? So we can create another variable called temp, which will equal to the cursor, both pointing to the first node. So both will contain the address to the first node. Now we will actually free this temp pointer, but we must make sure we do not lose access to the rest of the linked list. So we should move the cursor to the next node before we free the first node. Now we can free temp without losing the rest of the linked list. The cursor will then reach null that indicates we have freed up all the memory allocated. So what will our code look like? So first we will iterate through the buckets in the hash table. So for int I equals to 0 and as long as I is less than n, where n is the number of buckets in the hash table, we will increase I incrementally. So we'll set the cursor to the start of the linked list, and if the cursor is not null, we will free memory. So as mentioned, we will create a temp and it will equal to the cursor first. Then we move the cursor to the next node and free temp. Right, so we'll repeat this, and then when we reach the end of the linked list, that is when cursor equals to null, we will return true, which means we have successfully freed up the allocated memory up to the end of the linked list. So let's put all this and see. So as discussed, what we'll do is that we will actually go through the linked list within our hash table. So we'll set our cursor to be the head of the linked list first. So as we discussed earlier on, we'll set up temp, which will point to the cursor as well. And then we will first move the cursor to the next node, then we will free temp, right? And then after that's been done, what we will do is that we'll just keep repeating this. And if cursor equals to null, that means we've actually reached the end of the linked list. So we can actually just stop going through the linked list because we've reached the end already. Okay, so that's actually that for unload. So what we're going to do is that we can actually compile this. So let's just make speller. So I'll actually use the LaLaLand text as a sample. So /speller, then text /LaLaLand.text. So now we actually spell check the entire script. So these are all the incorrect words. And then you'll see that we also return stats like the words that we have actually misspelled, words in the dictionary, words in text, and the time spent in different functions. So we can actually open the LaLaLand text in keys. So this is actually the answers that we can tally against what we've just done to see if it matches. So as you can see, the number of words misspelled is 955, which is that is what we got. Words in text is also 17,756, which is what we got. And yeah, there you go. So this is the solution for problem set 5, which is speller. Thank you so much for watching this video, and if you found it to be helpful, please give it a thumbs up and subscribe to the channel. And I will see you in the next video. Thank you.